Good day, everyone, and welcome to where we are putting together solutions to those math and science areas where students are getting problems at the Form 5 CSEC level and the Form 6 KEEP level. In this video, we will be looking at CSEC Mathematics and specifically the topic of measurement with regards to perimeter, area, and volume. We'll be looking at the past paper questions from May 2009 up until 2013. Feel free to like the video and add any comments down below so we can help you in any areas that you need. Don't forget to look at the description down below where we have given a suggestion of the order in which to watch all the videos in order to get a better understanding of the CSEC Maths syllabus. Let's take a look at the major topics in CSEC Math, and we see that there are 10 of them. And in this video, we'll be concentrating on topic number 4, measurement. This comes as 8 questions in the multiple choice paper 1 and 1 whole question with 9 marks out of the 100 in paper 2. Measurement itself can be subdivided into 2 topics, scale drawings and perimeter, area and volume. In this video, we'll be concentrating on the second one. And we can see that in the formula sheets given in both paper 1 and paper 2 when we are writing the exams, there are 8 formulas that help us in this area. So they will give us the volume of a prism, volume of a cylinder, volume of a pyramid, circumference of a circle, length of an arc, area of a circle, area of a sector, and area of a trapezium. When we looked at the years from 2009 to 2013, there was no question that came in perimeter, area, and volume in 2009, but it came in all of the other years. Let's give a quick summary of this topic, where we look at the shapes from rectangles, squares, parallelograms, straight onto cone. And these are the major shapes that are tested. And how can we subdivide them? Well, from rectangles, squares, straight onto circle, those shapes are flat, so we can call them two-dimensional shapes. While the others, from cuboid, cube, cylinder, pyramid, and cone, those are three-dimensional shapes. So if we consider the perimeter of these shapes, remember perimeter means the distance around the entire shape. Then from the rectangle to the trapezium, we can use one formula to find the perimeter of all these shapes. And simply, it is to add up all the lengths of all the sides. While for a circle, because we can't see any straight sides there, then the formula is 2 times pi times r. And notice there's an asterisk there. And any formula with an asterisk on this table indicates that it is given in the formula sheet that we are given by the CXC body when we are writing both paper 1 and paper 2. And for the three-dimensional shapes, all of them, then we cannot find the perimeter around them because they are not flat shapes. Now let's look at area. Area can be considered to be the number of squares that are required to cover the entire shape. So for a rectangle, then it straight up to trapezium, from a rectangle up to rhombus, all those will be length times breadth, as long as the length and the breadth are at 90 degrees to each other. While for the triangle, it is half of a rectangle. And for the trapezium, it is a half a plus b by h. Notice that's also given in the formula sheet as well, where a and b are the parallel sides of the trapezium. And for circle, the area of a circle is pi r squared. And how do we find the area of the 3D shapes? Well, all those 3D shapes have multiple sides. So what they will be asking us would be to find the surface area, or the area of all the surfaces. So what we need to do is find the area of each surface and add it up. And for volume now, last part, for the volume of the two-dimensional shapes, volume would be considered to be the number of cubes that are required to fill the entire shape. And since these two-dimensional shapes are flat, then we cannot find the volume of these shapes. And the volume of the cuboid, cube, and cylinder, those which are what we call prisms, then it will be the area of the cross-section times the length or the height. Doesn't really matter what we call it. And for the pyramid and cone, then it will be 1/3 the area times the height. May 2010, number 3b. The diagram below, not drawn to scale, shows a wooden toy in the shape of a prism with cross-section ABCDE. So what does that mean? It means that if we cut this shape vertically downwards, then we will see the same face ABCDE throughout, straight from the front to the back. That means that the height of 5 centimeters in the back is the same as BC, the height of 5 centimeters in front, and the height of AE. Also, the slope at the back, which is 5 cm, will be the same as the slope in front at CD, which means that our front triangle CDE has two sides 5 centimeters each, which means it's an isosceles triangle. So if we look at that line coming down DF, it cuts the isosceles triangle exactly in half. Goes on, F is the midpoint of EC, and the angle BAE is equal to the angle CBA, which is equal to 90 degrees. Part 1. Calculate the length of EF. Since it told us F is the midpoint of EC and EC is the same as the base AB, which is 6 centimeters, that means EC is half of AB, which is 6/2, which is 3 centimeters. Part 2. Calculate the length of DF. So let's redraw that triangle DEF, and we can see that DE is 5 centimeters, they gave us that. EF is 3 centimeters, which we just worked out from part 1, and we need to calculate the third side. And let's recall, this is a right angle triangle, which means that if we have two sides and we want to find the third side, we can use Pythagoras' theorem. So O squared plus A squared is equal to H squared, where I'm calling O and A the two short sides. It doesn't matter which one is which, and H being the longer side. So let's put O as DF. So we have DF squared plus A as EF squared is equal to H, which is DE squared. So let's substitute DF squared plus 3 squared is equal to 5 squared. So 3 squared, 3 3s are 9 is equal to 5 5s are 25. So if we want DF squared alone, we have to remove the plus 9 from the left hand side and carry it across, which means to say that we're subtracting by 9. So DF squared is 25 minus 9, and we can work that out. That will give us 16, and DF would be the square root of 16, which is 4 centimeters. So we got the height of the triangle. And in part 3, calculate the area of the face ABCDE, which we have as the front face. So if we look at the area of the rectangle ABCE, look, we have it in a yellow square. What's the formula for area of a rectangle? Length by breadth. And it doesn't matter which side we call length and which one breadth, it will give us the same thing. So we say 6 by 5, and that is 30 centimeters squared. That's the area of the rectangle. And if we want to get the whole face, we need to get the area of the triangle. So the area of the triangle DEC would be length by breadth over 2, or base by height over 2. It doesn't really matter what we call it, as long as the two values we're using are 90 degrees to each other. So we have EC would be 6 times the height, which is 4, which we worked out in part 2, all over 2. So 6 4s are 24, 2 into 24 is 12. So we got the area of the rectangle, 30 cm squared. We got the area of the triangle, 12 cm squared. So the area of the entire face, A, B, C, D, E, is 30 plus 12, which is equal to 42 centimeters squared. May 2011, number 4b. In this question, use pi is equal to 22 over 7. Part 1. A piece of wire is bent to form a square. So we have a square there of area 121 centimeters squares. So we have the square and we cover the area. Remember, the area will be the surface, the number of squares that covers the surface, and we have that in blue. So calculate, part A, the length of each side of the square. So area of a square is the same thing as area of a rectangle, length times breadth, and both of them are the same. So that means we know we can substitute area of a square, they gave us that as 121, is equal to length times length, which is length squared. So if we want the length alone, we carry the square from the right hand side across, and the inverse of square would be square root. So the square root of 121 is equal to L. So L is equal to 11 centimeters. The perimeter of the square now. So the perimeter of the square means the distance around. So if we put a little x at one corner and we want to find the perimeter, what we need to do is to add L plus L plus L plus L, because they're all the same length. So that will be 11 plus 11 plus 11 plus 11. Remember, the perimeter of a shape is just to add up all the sides. So 11 fours are 44 centimeters. Part 2. The same piece of wire, which was 44 centimeters long, is bent to form a circle. So we have the circle here in green. Calculate, part A, the radius of the circle. So we can remember from our formula sheet that the circumference of a circle is given, and that will be 2 pi r. And what do we know? We know that the circumference is 44 centimeters because it's the same piece of wire. So we had it as a square, which was 44 centimeters long. We straightened it out, and then we bent it back to form a circle. So it's the same length of wire, so it's still 44 cm. And 44 cm is equal to 2 times 22 over 7, that's pi, which they gave us on top, times r. So if we want to find r, we can carry those things across. So we have the 2 is multiplying. When I carry it across, it will divide. The 22 is multiplying by the r. It's in the numerator. When I carry it across, it will be in the denominator. And the 7, which is in the denominator, when we carry it across, it will be in the numerator. So we got 44 over 2 times 7 over 22. 2 into 2, 1, 2 into 44, 22, 22 into 22, 1, 22 into 21, we left with 7 centimeters. So that's the radius. And the final part of the question, part B, find the area of the circle. So from the formula sheet, we know the area of the circle is pi r squared. So let's substitute. Area is what we want to find, is equal to pi 22 over 7 times, what's the radius? We got it in part A, 7 times 7, because it's 7 squared. So 7 into 7, 1, 7 into 7, 1, so 7 times 22 is equal to 154 cm squared. May 2012, number 4b. In the diagram below, not drawn to scale, shows a cross-section of a prism in the shape of a sector of a circle, center O, and radius 3.5 centimeters. The angle at the center is 270 degrees. Use pi to be equal to 22 over 7 in this question. So part E. Calculate, part 1, the length of the arc ABC. So we have a formula from the formula sheet. Length of arc, or S, is equal to theta over 360 times 2 pi r. And remember, theta is the angle in degrees. So the length of the arc, S, would be equal to 270 over 360, multiplied by 2, multiplied by 22 over 7, multiplied by, what's the radius? 3.5 centimeters. So we can use our calculators and work it out. If you're getting problems with the calculators, multiply the whole numerator, get an answer. Multiply the whole denominator, get an answer, and divide them. Or we can Let's work it out as is. From 270 and 360, 0 cancels 0, 9 into 27, 3, 9 into 36, 4. 2 into 2, 1, 2 into 7, 3.5, 3.5 into 3.5, 1, 3.5 into 3.5, 1, 3 times 22 is 66, 66 times divided by 4 is 16.5 centimeters. So that's the length of the arc. Part 2. Find the perimeter of the sector OABC. And remember, the perimeter of any shape is add up all the sides. So if we look at the sector OABC, there is the arc, and then there are 2 radii. So it means that there are 3 sides. So perimeter is equal to OA. If we start from O, we go up to A, and then we go from A, B, C, that's the length of the arc, and then from C back to O. So OA is 3.5 cm, that's a radius. Length of the arc, we worked out from part 1, is 16.5 cm. And length of OC is another radius, 3.5 cm. And that will give us 23.5 cm. Part 3. Calculate the area of the sector OABC. And we can look at our formula sheet. In the area of the sector is given as theta over 360 multiplied by pi r squared. And what's theta? Theta is 270 degrees over 360 multiplied by pi. They gave us that as 22 over 7 times r, 3.5 times r, 3.5. And we can use our calculators and work this out, and this will give us 28.875 cm squared. In this question, they didn't tell us whether to use it to round it off to 2 decimal places or not. So we can leave as is. And in part B now, the prism is 20 centimeters long and is a solid made of a tin. Calculate the volume of the prism. So we have the volume of a prism. Remember, a prism is one in which the cross-sectional area remains the same. And in our formula sheet, it tells us our first line up on top, the first formula given, volume of a prism is area of the cross-section times the height or the length. And we worked out area of cross-section from part 3. That was 28.875 multiplied by how long is this prism, or the height of the prism, 20 centimeters. And we can use our calculators and work this out, and this will give us 577.50 cm cubed. B, part 2. Last part of the question. The mass of the prism to the nearest kilogram is what we need to calculate, given that 1 centimeter cube of tin has a mass of 7.3 kilograms. So we can consider it like a ratio. 1 cm cube of tin has a mass of 7.3 kilograms. So what will 577.5 cm cube give us? And how do we know this volume? That was worked out in part 1. So it'll be 577.5 times 7.3, and that works out to be 4,215.75 kilograms of tin. And we're using our calculus to get this answer. Now let's go back and see if this is our final question answer. In part 2, they told us, we're reading above, in bold, to the nearest kilogram, which means we have to approximate our answer to a whole number. So 577.5 cm cube is approximately equal to 4,216 kilograms of tin. May 2013, number 4A. The diagram below shows an isosceles triangle CDE. And since it's an isosceles triangle, it means that 2 of the sides are the same. So we can tell that CE and DE are the same length. G is the midpoint of CD. So since G is the midpoint of CD, it means it cuts CD directly in half. It also tells us that we can see that G is directly below E. So EG is the height of the triangle. Part 1. Measure and state in centimeters the length of DE. So what they're asking us is to find how long DE is. And we can either use our divider by opening it and resting it from D to E, and then placing it without shifting the divider onto the ruler to get the length, or we can place our ruler directly from D to E, make sure that 0 is on E, and measure the length. And it will give us exactly 5.0 centimeters. Part 2. Measure and state in degrees the size of angle ECD. So let's recall that when we're measuring an angle, we need to use our protractor. And since it's saying angle ECD, let's see if we can draw a line from E to C and then from C to D. So we can see that the angle to be measured is that how much turn it is from one place to the other. So make sure that we rest our direct center of our protractor on C, line up the 0 degrees from C to D along that line, and then measure upwards. And that will give us 37 degrees. And finally, for part 3, determine the perimeter of the triangle. So how do we get the perimeter of triangle CDE? Perimeter means to add up all the sides. Now we already know DE from part 1, and they told us it's isosceles, so therefore we also know EC. So the only part that we're missing is CD. So let's go measure that with our ruler, and that gives us 8 centimeters. So the perimeter would be equal to DE plus EC plus CD, which is 5.0 plus 5.0 plus 8.0, and that is equal to 18 centimeters. And the last part of the question, part 4, calculate the area of the triangle CDE. So area of a triangle would be equal to length times breadth over 2, or base times height over 2, doesn't matter. So do we know our base? Our base is CD, which is 8 centimeters, and our height is EG, which we need to measure. So when we measure EG and we substitute in there, then we will get a total area of 12 centimeters squared. We've now come to the end of this video in CSEC past paper questions on the topic of measurement, and specifically perimeter, area, and volume. This video dealt with past paper questions from May 2009 to 2013, and our next video will be dealing with the next 5 years, from May 2014 until 2018. Don't forget to look at the description down below to follow the order in which we suggest to look at all these past paper question solutions so that you can get a better understanding of the CSEC Maths syllabus and therefore a better grade.